In 2012, a doctoral student in Japan made a discovery that rewrote our understanding of the sun. She wasn't looking at telescopes or satellites, she was looking at a tree, a 1,900-year-old Japanese cedar, cut down and preserved, its rings holding secrets no instrument had ever recorded. One ring stood out. The year 704 AD. Inside that thin band of wood, radioactive carbon levels had spiked by 12%. That's not a rounding error. That's 20 times higher than normal fluctuations. Something had bombarded Earth with radiation on a scale we've never witnessed in modern history. And here's the unsettling part. We still don't fully understand what it was. Miyake, the physicist who made the discovery, had stumbled onto evidence of a solar storm so powerful it made the Carrington Event look like a flashlight. The 1859 Carrington Event is our benchmark for solar catastrophe. It set telegraph offices on fire. It caused auroras visible in the Caribbean. If it happened today, it would cause trillions of dollars in damage. The 774 AD event was at least 80 times stronger. Let that sink in. Trees, it turns out, are nature's hard drives. Through photosynthesis, they absorb carbon dioxide from the atmosphere, including a radioactive isotope called carbon-14. When cosmic radiation hits Earth, it creates more carbon-14. Trees record that spike in their annual growth rings, preserving the evidence for centuries, millennia even. After Miyake's initial discovery, scientists around the world started checking their own ancient wood samples, German oaks, Russian pines, American bristlecones, New Zealand kauri trees. The same spike appeared everywhere. Whatever happened in 774 AD, it was global, and it was instantaneous. But 774 wasn't alone. Researchers have now confirmed 6 of these events, stretching back over 14,000 years. They occurred in 776 BC, 5410 BC, 5259 BC, 674 AD, and 993 AD. Scientists call them Miyake Events, and the largest one we've found, buried in ancient trees recovered from a river in the French Alps, was nearly twice as powerful as 774. So what causes them? The leading theory is solar superflares. Our sun, despite appearing calm and steady, is capable of eruptions far beyond anything recorded in modern history. Observations from the Kepler Space Telescope have shown that stars similar to our sun can produce flares hundreds of times more powerful than the strongest we've measured. If the sun fired one of those at Earth, the energy would dwarf every nuclear weapon ever built, combined. But here's where the mystery deepens. When scientists analyzed all the tree ring data, they found something unexpected. Miyake events don't align with the sun's 11-year activity cycle. Solar flares typically cluster around solar maximum, when sunspot activity peaks. These ancient superflares, they seem to arrive randomly. Some hit during solar maximum, others during minimum. The pattern, if there is one, remains hidden. Some researchers have proposed alternative explanations: supernovae, gamma-ray bursts from distant stellar explosions, even comets. But the evidence keeps pointing back to the sun. Ice cores from Greenland and Antarctica show matching spikes in other isotopes that trace solar activity. And historical records from 774 AD describe something remarkable. The Anglo-Saxon Chronicle, a 9th century collection of annals, mentions a red crucifix seen in the sky after sunset. Chinese astronomers recorded unusual celestial phenomena that same year. They were describing an aurora, but not the gentle northern lights we photograph today, something far more intense, something that reached latitudes where auroras should never appear. Now, imagine that happening tomorrow. A Miyake-level event would do more than create pretty lights. The radiation pulse would damage satellites within minutes, GPS systems would fail, communication networks would collapse. The electromagnetic surge that followed would induce currents in power lines strong enough to melt transformers across entire continents. Some estimates suggest such an event could cause an internet apocalypse, with submarine cables and data centers going dark for weeks or months. And we'd have almost no warning. Solar energetic particles travel at nearly the speed of light. By the time we detected the flash, the radiation would already be here. The probability isn't as remote as you might hope. Miyake events occur roughly once every 1,000 years. That's a 1% chance per century, a 1 in 10 chance per millennium. We're currently in the longest gap between confirmed events in the historical record. The last one was 993 AD, over 1,000 years ago. Statistically, we're overdue. The trees remember what we've forgotten. Somewhere in the rings of ancient forests lies evidence of catastrophes that would end the modern world as we know it. The sun has done this before. It will do it again. The only question is whether we'll be ready. Those Japanese cedars Miyake studied are still standing in labs around the world, still holding their secrets. What else might they tell us if we learn how to listen